Greetings. Prepare yourself for astounding revelations. Today, our topic of discussion delves into the concept of certainty, as explored by author and theorist Charles Aprile. A thrilling journey lies ahead. Whether you're a seasoned scholar or a curious novice, if you've dipped your toes into the waters of physics, chances are you're acquainted with both quantum and classical theory. And nestled within this fascinating realm lies the enigmatic uncertainty principle. However, what is Aprile's certainty principle? We will not be concentrating on a mathematical equation here, but rather on a fundamental principle governing particle interactions. At its core, certainty refers to absolute assurance, the absence of ambiguity or hesitation. It's that unshakable belief that the sun will rise tomorrow, that water is wet, and that gravity keeps us grounded. However, in this intriguing perspective in which we will be discussing, the concept of certainty illuminates the universe from a fresh angle. It introduces an idea that fundamentally alters our interpretation of particle interactions, weaving a connection that allows us to delve into the very origins of Einstein's theory of relativity. Notably, this exploration also unravels the enigma of time dilation. Let's embark on our journey of understanding by weaving an analogy into the fabric of our exploration. Imagine, if you will, Einstein perched on his bicycle at the crest of a hill. If he were suddenly nudged off that hill, unable to steer, we would observe an increasing uncertainty in his trajectory as he randomly descended downward. Without steering, the likelihood of following a single path would ultimately decrease. Now picture the same scene, but this time it's both Heisenberg and Einstein perched atop the hill. Not on their individual bicycles, mind you, but rather cozily seated together on a tandem bicycle. Suppose their tandem bicycle were nudged off the hill once more, still without the ability to steer. In this scenario, we would indeed observe the same outcome: an uncertainty regarding their path. From their frame of reference, the uncertainty regarding the bicycle's path would remain consistent, whether it's a lone rider on a single bicycle or two riders pedaling in tandem. However, there exists a profoundly significant shift, one we must thoroughly grasp and comprehend if we aspire to unravel the intricate behaviors of our universe. And here lies the crucial realization. Another frame of reference emerges. While the tandem bicycle will ultimately harbor the same uncertainty in its path, we can state with unwavering certainty that Einstein, the rear rider, will invariably trace Heisenberg's trajectory. Viewed through Einstein's lens, he would ascertain with complete certainty that Heisenberg is perpetually at his side, maintaining an unvarying velocity and distance relative to his own. Hence, yet another frame of reference emerges, one that possesses absolute certainty regarding both speed and position relative to the other rider. Remarkably, just as Einstein has a reference to Heisenberg, the reverse holds true. Heisenberg also maintains a reference to Einstein. Indeed, within this system, or in other words, the tandem bicycle, uncertainty persists in regard to the system as a whole. However, each rider unmistakably forges an additional frame of reference, one of certainty in relation to each other. Inexorably, they weave a shared reference, unassailable and undeniable. In a sense, they craft their own relative compass, where uncertainty to other objects remains, but certainty to each other is now a reality. Keep in mind that, while the system currently exhibits a degree of uncertainty, there exists an alternate particle interaction mechanism that has the potential to transform this uncertainty into certainty. However, we will reserve the exploration of this intriguing concept for a future discussion. The emergence of an additional frame of reference in this context highlights the gaps in our current comprehension, particularly regarding the intricacies of particle interactions and electromagnetic bonds. In our initial thought experiment, we ascribe uncertainty in the path as our ultimate assumption. However, in reality, while this holds partially true, more intricate dynamics come into play as we introduce a so-called bond between both riders. Of course, this is a mere thought experiment. As we are well aware, particles possess their own distinct behavior, separate from that of classical objects. However, consider this. What if particle interactions, like the delicate interplay of electromagnetic forces, reshape the very essence of particle behavior? Imagine uncertainty metamorphosing into certainty, when particles tango together, and behold the consequence, relative frames of reference emerge. In his thought-provoking book, Unification with Certainty, Bridging Quantum Classical Theory, Charles Aprile delves into this intriguing idea and explores other captivating questions as he elaborates on these topics. Inserted within the description below, you'll find a link to his book that captivates with its depth and insight. The tantalizing concept of current theories being correct, while simultaneously grappling with incompletely defined forces, such as particle interactions, invites further exploration. In the tempting gap between our current theories, accurate yet incompletely defined, lies the bridge between quantum and classical theory. This alternative explanation doesn't seek to disprove or overturn what we already accept as fact. Instead, it delves deeper into the cosmic fabric, aiming for a more complete and accurate description of our universe. If you're curious about exploring more, consider our video on time, where Charles Aprile's groundbreaking visions on time unfold. Thank you for joining us in exploring this intriguing concept. Until next time.